Now see in this question, this is the transient based question, and in transient we are having which circuit? It's R and C. So RC is the first order, right? So in this they said in the below circuit the switch is open for a long time of before it is closed at time t equal to 0. Means at time t equal to 0 the switch is closed, before that it was open, right? So remember I told you the formula for that Vc of t. Remember what was the formula for that? Vc of t is equal to V infinity, then plus Vc of 0 minus, then minus Vc of infinity, then e raised power minus t by tau, right? So then also we can apply this equation. Yes, this is the RC circuit. Yeah, I'm telling you the steps stepwise only. Step number 1, at t equal to 0 minus you need to draw the circuit. Okay, before the switch was like t equal to 0, it may be not, it's not necessary na, that it would be opened or closed. That depends on the switch position. So at t equal to 0 minus draw the circuit. If it is RC circuit, then calculate Vc of 0 minus. If it is RL circuit, then in that case you need to calculate IL of 0 minus. Okay, and as you already know, Vc of 0 minus is equal to Vc of 0 plus, IL of 0 minus is equal to IL of 0 plus. Yes, I'm writing here also. If there is a capacitor, then that would be open circuit, and voltage we need to calculate it across those capacitor points only. But if there is an inductor, we need to calculate, we need to short circuit the inductor, and then we need to calculate the current across that points only. Okay, clear? For capacitor, like suppose this is the case at t equal to 0 minus. So at t equal to 0, the switch is closed. Before that, the switch was opened or closed? Before that, it was opened. So that means there is no current flowing across through this. Yes or no? So can we do the redraw the circuit like this at t equal to 0 minus? If there is no current flowing across this, then there would be no, and there is not necessary to make the diagram, right? And as I told you, capacitor would be open circuit, right? So this would be A, this would be B. So ultimately you need to calculate Vc of 0 minus, that would be equal to VAB, right? VAB is how much? This one resistor. Is there any current flowing through this resistor? Huh? No. So the voltage across that would be also 0 only, because if there is no current, it's an open circuit, so that would be voltage would also be 0. Okay, so we need to convert, can you convert this current source into the voltage source, or can you calculate the voltage across 40 ohm? That would be the Vc of 0 minus only. Calculate it, the voltage across 40 ohm. Right. So that would be how much? 80 volt, right? Vc of 0 minus, we got it as 80 volts. So we can write down that our first step is completed, that we got Vc of 0 minus as 80 volts, correct? Now step number 2, at t equal to 0 plus we need to redraw the circuit. Okay, in this case the switch is closed, right? And particularly for that we need to calculate VC of infinity again, right? That was VC of 0 minus we calculated before. Now if the switch is closed, then the circuit is like this. Yeah, so that would be at t equal to infinity, or you can say 2 ampere, 40 ohm, 12 ohm, right? And this 20, and that would be again open circuited. So this is, we want to calculate VC na, VC of infinity. So whenever we need to calculate VC of infinity or VC of 0 minus, in that case capacitor must be open circuit, because across those 2 points only you need to calculate the voltage. Okay, so 40 and 120 and 20, and this is 2. Now calculate it. Yeah, 20 resistor will not work because it's a 0. We can combine 40 and 120 to a single resistance, and what would be the voltage? Yes, it's 60, correct? So that would be VOC is how much? We got it as, basically VC of infinity we got it as 60 volt, right? Now we can, now step number 1 done, step number 2 done. Now step number 3, we need to calculate the time constant, right? So for time constant, if there is RL circuit, tau is L divided by R equivalent. If there is RC circuit, then tau is equal to R equivalent multiplied by C. If there was inductor for the step number 2, then we need to calculate IL of infinity. Again, inductor would be marked as short circuit. Yeah, that would be IL of infinity. Yes. Now we need to calculate R equivalent. So for t greater than 0, what are the steps for calculation of R equivalent? Voltage source must be, tell me, short circuit or open circuit? For the calculation of R equivalent, we need to calculate R equivalent, right? Now I am asking for calculation of R equivalent, voltage source must be short circuit or open circuit? All the sources would be removed, and voltage source must be short circuit or open circuits? And current source must be, okay, yeah, that must be short circuit, and current source must be open circuit. Okay. Now see, at t greater than 0, the circuit is, if for tau is, current source is open, 40, 120 and 20, and we need to calculate the resistance across those same points where the capacitor was there. Okay, so this is, as I told you, current source must be, but I wrote it here, current source must be so that's why I make current source must be open. Yes or no? Now calculate R equivalent is, how did you calculate 40 and 120? They are in parallel. Combined it into single resistance. Then that must be in series now. This 20 must be in series. Tell me how. 40 parallel 120 is how much? 50, right? So tau we got it as how much? Sorry, R equivalent we got it as 50. VC of infinity we got it as how much? 60, right? VC of 0 minus we got it as 80, and you can substitute the value. E raised to power minus t by tau. Now you need to calculate tau. Tau is R equivalent multiplied by C. Calculate it. They have given as 1 microfarad. 1 microfarad means, okay. Now you can substitute it, then you will get the final answer. Okay. Okay, let's move to another question. This is the voltage across inductor. Okay, clear? So see, every step in inductor case we are having IL of t. We need to put it in this formula. IL of 0 minus was 0. IL of infinity we calculated by switching close switch. V by R 0.5, and then we calculate R equivalent. There is only single resistance R, 200. So we calculated R equivalent, and then we calculated tau. Tau is how much? L divided by R equivalent. We simply substitute all the values, right? After substituting the values, then we'll get current, and if they are asking the voltage across inductor, then we'll use this formula. VL of t is equal to L di by dt, and then we differentiate. Okay. So see, you have seen that for capacitor and as well as for inductor, the steps are same, right? Okay. Now see, again in this case they are asking VC of infinity, the steady state value of t, basically VC of t, right? So how will we get VC of t? Again, first of all we need to calculate VC of 0 minus, and that how can we get VC of 0 minus at t less than 0, t equal to 0 minus circuit. So tell me, at t equal to 0 minus, the switch is closed or opened? We need to put time as infinity here. Yeah, we'll use it. VC of 0, okay. Tell me, what is the formula for VC of t? VC of 0 minus, no, VC of infinity plus Vc of 0 minus Vc of infinity e raised to power minus t over tau, right? So now tell me, at t equal to 0 minus, what is the circuit? Switch is open. If switch is open, then the diagram would be like this. That means Vc of 0 minus is 0 only. Now after this we need to calculate Vc at t greater than 0. Capacitor will behave as open circuit. Inductor will behave as an open circuit. Inductor will behave as a short circuit. And here the points A and B we need to calculate Vc of infinity. Now tell me, how can we get Vc of infinity, or we can say V of AB? No, we need to calculate the voltage across this resistance also, no? Hmm. Hmm. Tell me the value. Voltage, how much you are getting? 33 point. Okay, that is 100 volt. And you need to calculate I into R. That would be plus 100. And 100 into 2, 50. So 100 minus 50, 50 volt now. See here, the current is flowing like this, 2 ampere, but we are flowing like this, positive, negative. So opposite case, 100 minus 100 into 2, 200, 200 minus 100, 100 volt only. You are getting minus 100 volt. Okay, Vc of infinity you are getting minus 100. Understood? No? Okay. See by my method, please. You are standing at A, you need to move towards B. Yes or no? Okay, then do it by yourself. You can calculate, we are trying to calculate the voltage across A and B. This point and this point. I need to tell you my method or no? Yes or no? Then do it by yourself. I don't know. You are standing at A, you need to move towards B, right? 100 volt is the voltage drop. Yes or no? Then there is a voltage drop across this 100 volt also, right? So C, this is market, this point as A, this point as C, this point as D, this point as B, right? So VAB is how much? VAC plus VCD plus VDB. Can we write it like this? VAC is how much? 100 volt. And now we need VCD is how much? There is no resistance, no current. So the voltage across CD is how much? is 0. Yeah, if nothing is there, then that voltage across CD would be 0 only. Now, how can we get the voltage across DB? V is equal to IR. Very good. So R is how much? 100. And current is how much? 2 ampere. But see, it is flowing in the opposite direction. Yes or no? Because you are moving from D to B and current is moving from the opposite or the same direction. Yeah. So it would be minus 200, minus 2, because both are in the opposite direction. So 100 minus 200 is how much? Minus 100. This is the answer. In this question, they ask you to calculate VC of infinity. So VC of infinity is only minus 100 volt. If they ask you to calculate VC of t, then you need to calculate VC of 0 minus, that was 0. VC of infinity is minus 100. Then in that case you need to calculate tau. Okay, but in this particular question they are not asking VC of t, they are asking only VC of infinity. That is minus 100. You can, yeah, check the answer also. Answer is also the same. Which one? Now see, in this question they said consider the following circuit in which current in an inductor is driven by a DC source. Estimate the time constant. Time constant tau is equal to L divided by R. Did you send me the solution for this particular question? No, solution I'm asking. They are asking the time constant. Like time constant, we are having another value for the time constant, or we can say another formula for the time constant. The time constant is equal to time taken by the current to reach 63% of its final value. Okay, when 63, yeah, there is a fixed 63. So according to this, the final value it reaches around 3 ampere, right? 3 milliampere actually. If you calculate the 63% of 3 milliampere, then how much it would be? Calculate it. 1.89. Okay, so yeah, 1.89 milliampere. So 1.89, it would be 1.89 milliampere. So 1.89 is something like this at this point. Okay, so if we'll see the time constant from here, then time constant is how much? 2 milliseconds. Yeah, it is approximately 1.89. So they are consider the time constant as 2 millisecond. So the thing is, whenever they'll give you the graph, then in that case you have to see the 60% of the final value. Okay, at that particular we are getting 1.8 something, like approximately 2. So at 2, how much is the time? 2 millisecond only. So time constant for RL is 2 millisecond. Okay, now they said estimate the size of the inductor. As you know, the formula tau is equal to L over R. If tau is 2 millisecond, means 2 into 10 raised to power minus 3. L we don't know. R is given in the question 1 kilo ohm. 1 into 10 raised to power 3. So how much is the L for this particular case? L is equal to 2 Henry or millihenry? Yeah, L is equal to 2 Henry, right? Now they are asking the estimate the voltage level of the DC source, means we need to calculate the voltage according to Ohm's law. I we got it as how much? I current how much we are getting? 3 milliampere, right? So V is equal to I into R. Voltage we need to calculate. I is 3 milliampere, means 3 into 10 raised to power minus 3. Resistance is how much? Resistance is how much they have given to you? 1000. So 1 into 10 raised to power plus 3. So what would be the voltage? The voltage is 3 volts, right? So the answer is 3 volt. Now they are asking estimate the energy stored in the inductor. Remember I told you what is the formula for the energy? Energy of inductor. Hmm? Yes, correct. So energy formula is, what is the formula for C? Hmm. Okay. Now do you know the value for L? And do you know the value for no, L we got it as 2 na? And do we know the value for current? Yeah, put down all the values. Tell me the answer. Two से two cancel. 3 3 is 9. 10 into 10 raised to power 9 into 10 raised to power minus 6 joules. Right? So can we say that 9? Okay. Now this was the answer. Now they're asking calculate the total energy delivered by the source over the entire changing process. Means they're asking the energy across the source. Earlier they have asked you to calculate the energy across the inductor, right? So energy is how much? Power into time. What is the formula for the power? So can we say that V multiplied by I multiplied by T? What is voltage? We calculated 3 volt. I we didn't know. Time will remain time. I is how much? No, we need to calculate. See, it is the case of inductor, so we need to calculate I of t. I of t again we can calculate it by that formula only. IL of infinity plus IL of 0 minus plus IL of infinity e raised to power minus t over tau, right? IL of 0 minus is how much for this particular case? Like it would be 0 only. And IL of infinity is how much? V over R. P is how much? Voltage we have calculated earlier now. P V over R. P. Resistance is how much? So 3 over 1000 is how much? Okay, so that would be again IL of infinity means 3 over 1000 e raised to power minus t by tau. Tau is how much? We need to calculate R equivalent. How much is the R equivalent? Hmm. Hmm. Yes, only 1000. R equivalent is 1000. Tau is how much? L over R equivalent. L is how much? Hmm. L how much will you calculate it? Okay. So 2 by 1000, right? 2 by 1000. Now I put all the values. Tell me what is the final answer for IL of T? Hmm? The final answer for IL of T. And what 3 by 1000, right? This is minus 1 minus e raised to power minus t. 2 by 1000 is 500. So minus 500t. You got this one or not? Just see it and then tell me. Hmm? Do I need to explain once again? Hmm? Okay, IL of T we got it. This one, can we put the value over here? So we need to calculate power first. Power is equal to V multiplied by I. V is how much? 3. I we just calculated 3 by 1000. 1 minus e raised to power minus 500t. Yes. Hmm? So it would be 9 by 1001 minus e raised to power minus 500t. Got it? Now for energy we need to integrate it. See, according to the graph, time vary from 0 to 10 millisecond. Yes or no? Time is varying from 0 to 10 milliseconds. So for energy, that is power multiplied by time, energy is how much? Power we got it 9 by 1000, 1 minus e raised to power minus 500t, and limit vary from 0 to 10 d of t. Okay, now you need to solve it. 9 by 1000 is constant. You can take it outside. 1, then you can do it further, I think, right? It's an integration.